The different stuff, VPD, vapor pressure deficit. Okay, VPD, that's vapor pressure deficit. For anybody out there taking notes and writing it down, I'll say it again, vapor pressure deficit, VPD. Okay, guys, what this is going to be, this is the relationship between the temperature in the air, the humidity in the air, and the surface temperature of your leaves. So the way that plants work is the plants have small little openings, and I always think of them just in my mind's eye, they look like mouths. They're little tiny holes that are in the leaf surface, and that's how the leaf actually breathes, basically, okay? And as most of us know from, early earth science class, that plants breathe in CO2 and they take out and they breathe out oxygen, okay? And so they do that through the little pores called stomata. Some of you may remember that term, the stomata. Okay, so the stomata, what they do is they work through a relationship between the pressure inside the leaf and the pressure outside the leaf. It's called a process, it's an osmosis process. It's a process of there being, if you ever know how a straw actually works, it's just the difference in pressure from one place to another that will actually cause different things to transfer. Ions will transfer this way, water transfers this way. There's a lot of different things, okay? And so in this case, we're talking about the difference in the air temperature, the leaf temperature, and the relative humidity in the air. So this is all a bunch of numbers that can get crunched and numbers that you can take. There's a lot of VPD calculators out there that'll show you a VPD chart. Your VPD charts are going to range because ultimately this is still kind of just, anecdotal evidence, so to speak, just because it's kind of a hard thing to test. And so you'll get the different VPD charts. And so what it's going to be a chart that looks like this. You're going to have relative humidity on this side or down here. Can't remember which one it is. You're going to have temperature on one and relative humidity on the other. And so what you're going to be able to do is you're going to be able to tell you, okay, my temperature is 78 degrees and my relative humidity is 48%. You match those up and you find out you're going to get a number. It ranges from, 0.4, 0.5 or whatever, 0.3, but that's out of range, all the way up to 2 or 3 or whatever. So there's a range in which the different plants, for different plant stages, there's a different range in VPD for what you want. And so you can actually there's a lot of different, like I said, VPD calculators out there that'll let you know what the specific VPD you should be in and what range you should be in for what stage your plant is in. Okay, so if it's at a seedling stage, generally you're going to be one around a 0.8, 0.6 to 0.8. Okay, that's going to be, and again, just reference a VPD chart. They're easily Googleable things. VPD calculator, vapor pressure deficit calculator. And that'll be able to give you your range. And then you can just look up any basic, VPD chart or look up a bunch of them, cannabis-specific VPD charts. So you'll be able to, David, what's up? You'll be able to get your VPD and then match it to the chart. That's going to let you know the optimum rate at which that plant is breathing, okay? It's going to be the rate in which it is transferring, essentially, water from its roots, from the soil. So the water goes from the soil into the roots through, again, that's an osmotic process that the water goes into the roots. The water travels up the plant through the xylem and the phylum, through the phylum, and it goes up into the plants and it goes into the leaf tissues where it needs to expel that oxygen because it's built it up and through the plant's processes has gone up and it's actually, converted that oxygen into CO2, which it could use. So by the time it gets to the leaf and it gets to the stomata, it breathes it out, all right? So you'll see everybody, I'm sure you guys have seen plants that pray. They're praying, they're doing good, they're praying. It's great, man. That's great. That means that it's always great to see it. It's a fantastic thing to be able to visually see on an almost microscopic level what's happening in that plant and what's happening in that leaf. Okay, that you're getting that plant to go. Oh man, it's breathing. It's you're getting the best that you possibly can. And when you're enriching it with CO2, for the folks out there that are using CO2, I always do. I always believe it to be a very key factor in getting autos to grow big, huge, giant, and super awesome yields. Not everybody's set up for it, but with CO2, what it's doing is like, I live up here at 9,000 feet elevation, and they have a local college here that is the national champions of long distance running, cross country running, okay? They are absolute monsters. They are beasts. They are so crazy, all right? The reason being is because they train up here at 9,000 feet, and they get their lungs all built up to this low oxygen environment, when they go down to sea level, they just outrun everybody. They just outlast everybody because their breath is. I can only imagine that when you're enriching CO2 in your environment, that it's kind of like that. It's like going from way high to down low and just being like, whoa, I feel like Superman. You know what I mean? That you're getting maximum capacity. You're getting optimum environmental inputs. So VPD is a real good way to be able to, everybody's like, hey, what's my temperature supposed to be? Is my humidity too high? That if you can actually just get your VPD in check and get, it's cross-referenced to a chart, you can adjust to where you need to be. And so let's say, for example, that your humidity is too low, which is the case in my case almost always, that if your humidity is too low and your temperature is too high, which is a lot of the case, a lot of the times, that you'll be able to introduce a humidifier, maybe some cold air, maybe get a vent that's on top of your fan, whatever the case may be, to try to reduce, try to get those two inputs to come closer on your chart. All right, so the higher you bring your relative humidity and the lower you bring your temperature, you'll get it down in that range, okay? And so if you can keep it in that range, then you're good. Then you will see that keeping your optimum root zone environments for autoflowering cannabis is optimal. Now we're going to be talking about the air.